prime factorization by factor tree method. So this is the method we are going to concentrate on in this lesson. Factor tree method. Something you are remembering, isn't it? You have done it in class 4. Yes. So let's see how does it look like, or how do we do it. Factor tree method. The first sum that I have taken over here is prime factorize 18, number 18, using factor tree method. Now I have made a small little tree over here, children. Obviously you don't have to make it. In the next slide you will see how you are going to do the sum, okay, in your notebook. It's going to be the same thing, but note please are to be made. Okay, this is here just for fun, nothing like that. So prime factorize it 18 using factor tree method. Now 18 will be written on top. 18 will be written on top, and there will be two branches like this that will come out of 18. Two branches. Can you see the two branches? Yes. So these two branches will come out of 18. Now you can take any number which divides 18 completely without any remainder. Any number, children. Okay. There is no set rule of which number to be taken. Now the first number that comes to my mind, 18 is an even number. So the first number that comes to my mind is number 2. Because I am well aware of the divisibility rules also. Even you all are. So whichever divisibility rule that comes to your mind, you can take that. So an even number, 2, will be a factor of an even number. So on one side, we have written 2. What about the other branch? What do we write here? Now 2, how much 18 will be written on the other branch? Just below the other branch, what is multiplied by 2 to get 18 will be written over there. So it is 9. Yes, 2 9s are 18, right? So now we have got 2 9s are 18. Both branches have been filled. Now remember, children, the method is prime factorization, using factor tree method, prime factorization. So whenever you get a prime number, you don't have to factorize it again. Like here, 2 is a prime number. So we will not factorize it anymore. We have got a prime number here. But is 9 a prime number? No, it isn't. You all know that. It is not a prime number. And what are the factors of 9? Apart from 1 and 9, we are not going to use those. There is only one more factor, 3 and 3. How much are 9? 3 3s are 9, right? Now are these numbers prime, like 2 and 3 and 3? Yes, they are. So our sum is over. Once you get prime numbers, your sum gets over there. It ends over there. You cannot factorize it anymore, because the concept is prime factorization. We need to have the prime numbers as the factors, and we have got them over here. Can you see? So let's quickly circle all the prime factors. 2 is a prime factor of 18. 3 is a prime factor of 18, and this another 3 is also a prime factor of 18. So the answer is 18 is equal to 2 into 3 into 3. Correct. Okay. So if you multiply 3 into 3 into 2, you will get 18 back. 3 3s are 9, 9 2s are 18. You will get 18 back. So this is how we factorize or prime factorize a number using factor tree method. We will do many more examples. Let's see which is the next example. You can see it on the screen. Prime factorize 56 using factor tree method. Now we have taken a little larger number, 56, using factor tree method. Now 56 we have written on top, and there are two branches coming out of it. See, there are two branches which are coming out of it. You can take any factor, whichever factor comes to your mind. There is no set rule, as I said. Let's see, what have I taken? I have taken 7. That came to my mind first. So I have taken 7 here. You can take 2. Because it's an even number, you can even take 2. That's not a problem. So whichever number completely divides 56 without any remainder can be written below one of the branches. Now 7, how much are 56? 7 8s are 56. Correct. So see, now we have got 7 and we have got 8. Is 7 a composite number? No, it isn't. So that is why there are no branches. But 8 is a composite number. So there are 2 branches coming out of 8. Now let's see what have I taken. 2. 2 how much are 8? 2 fours are 8. Right. Again 2 is a prime number. So no branches. It is over here. But 4 is a composite number. So we will have to continue. 4 apart from 1 and 4. 4 only goes in 2's table. 2 2's are 4. So have we got all the prime numbers? Let's see. Is 7 a prime number? Yes, it is. So circle it. Is 2 a prime number? Yes, it is. And there are 2 more 2's. So circle all of them and write the final answer. 56 is equal to all the circled numbers. Why? Because they are the prime factors. They are the prime numbers over here used to prime factorize 56 using factor tree method. So 7 into 2 into 2 into 2 is the answer. If you multiply, you will see that you are getting 56 back. When we multiply the factors, we get the original number back. Remember, that was the rule of prime factorization or any factorization for that matter, right? So this is how we do prime factorization using factor tree method. Yes, correct. Now let's see which is our next sum. Let's take another example. Prime factorize 120 using factor tree method. So a little larger number has been taken here, children. It's a 3-digit number, 120, but a simple number, isn't it? So as you can see, this slide looks like your notebook, isn't it? We have got check sheet over here. So this will tell you how to do the sum in your notebook. So 120 is written on top, as you can see, and there are 2 branches that are coming out of it. So we can take any numbers. There is no compulsion, as I had already told you. So let's see which number have I taken, which will factorize 120 completely without any remainder. So I have taken 2. Now 2 is already a prime number. So what will come in the other branch? 2 how much are 120? Do we know that? Now you may make a rough column and find out. You can divide 120 by 2. But it is a simple number. You all are big now in class 5. You should be able to do it mentally. That is why I have not shown you a rough column here. Okay. So 2 how much are 120, children? 2 60s are 120. Yes. And 60 is a composite number. That is why there are 2 branches coming out of it. 2 is a prime number. So 2 is the prime factor and 60 is the composite factor. But the rule says we have to get all the prime factors. So we will have to factorize 60 again. Now what can I take for 60? Let's see, what have I taken? I have again taken 2. 2 how much are 60? 2 30s are 60. Now as you can see, 2 is a prime number. Yes, this 2 is a prime number. This 2 is a prime number. But 30 is a composite number. So that is why the branches are coming out. We need to factorize 30 again. Let's see now, what have I taken? Okay, it is an even number. So again and again I'm getting an even number, and the first thing that is coming to my mind is the divisibility rule of 2. All even numbers are divisible by 2. So I am taking 2 again and again. 2 how much are 30? 2 15s are 30, right? Is 15 a composite number? Is 15 a composite number? Do you all know that? Yes, it is. Don't think that all odd numbers are prime. No, it is not like that. 15 is a composite number. So now what do I take? I am taking 3, and 3 how much are 15? 3 5s are 15. You all are well aware of the prime numbers. So you all can see 2, 2, 2, 3 and 5. They are all prime numbers. So let us circle them. We have got all our prime numbers. There are no composite numbers left to be factorized. So let's circle the prime numbers. Yes. Okay. So we have got our prime factors, and we can write our answer as 120 is equal to 2 into 2 into 2 into 3 into 5. So as you can see, there are 3 2's, 1 3 and 1 5. And if you multiply all of them, all these small factors, you will get the original number back, which is 120, isn't it? So you can try doing that. You can multiply and check whether it is correct or not. It is correct. I am telling you that. But you may check. Why not? Isn't it? So this is one way of doing 120's prime factorization using factor tree method. Okay, but as I am telling you again and again, children, there is no set pattern of doing it. You may do it in some other way, and that is why I have taken 120 again, to show you some other way of doing it. Now there can be many other ways of doing it. I am just going to show you 2 ways of doing it. Okay, this is just for your convenience, for you to know that it can be done in many ways. Okay, so 120, let's see what have I taken. I can see there is 0 at the end, so I have straight away taken 10 as the factor, because I know the divisibility rule of 10, which says any number that ends with a 0 or which has 0 at its ones place is divisible by 10. So 120 divided by 10, we have done these kind of sums, isn't it, in division chapter? What do? There is a quotient which is 12, because the remainder is 0. We don't have to write it. We have already done this, isn't it? You all know how to do it mentally. Now children, here 10 and 12 both are composite numbers. Okay, so this is another way of doing it. Both are composite numbers. That is why you can see that both numbers have got branches under it. So let's see. 10, let us factorize 10. What do we have? We can take 2, and 2 how much are 10? 2 5s are 10. Yes. Now let us factorize 12. What can we take for 12? 10 is already done. Now let's take 12. What can we take for 12? Yes. 6. 6 how much are? 6 2s are. Now 2 is again a prime number here. 5 is a prime number. 2 is a prime number. But 6 is a composite number. So we will have to factorize it further. 2 3s are 6. Now can you see children? All these numbers which you can see are prime numbers, isn't it? So let us circle them. 2 is a prime number. 5, again 2, then 3, and then 2. So all these are prime factors of 120. Let's write the answer. 120 is equal to 2 into 5 into 2 into 3 into 2. Now as you can see children, it might look different because you have placed the number in different manner, but the factors are same. Here also you had 3 2's, 1 3, 1 5. Here also you have 3 2's, 1 3 and 1 5. And you know, property of multiplication says even if we change the order of the numbers, answer remain same. There is no change in that. So it's just the change of the order of the factors. Otherwise answer is same. So the whole idea of doing it 2 times was to tell you that particular number can be factorized in different manner. There is no set rule of doing it. I could have also taken 3 as a factor. I could have taken 4 as a factor. Okay, no problem. I could have taken 20 as a factor. Any manner you can do it, it will remain same. The end result will be same. Okay, only thing we have to keep in mind is that the factors should be prime at the end. Okay, let's see another example. Prime factorize 792 using factor tree method. Now it's a bigger number, although a 3-digit number, but little larger. So it's an even number. Whenever it's an even number, children, the first thing that should come to your mind is that 2 can be a factor. Okay, now I have not made a rough column, but you need to do it mentally. How do we do it? Let's see. We know 2 3s are 6. See on top. 2 3s are 6. 7 doesn't go in 2's table. So 2 3s are 6. But here it is 7 written. So there is 1 extra. Now that 1 extra is written with 9. And this becomes 19. Okay, this becomes 19. But 19 again doesn't go in 2's table. So what does the number that we can take? 2 9s are 18. We can take 2 9s are 18. 7 didn't go, we took 3, 2 3s are 6, 1 was extra, it became 19, 19 again doesn't go, so we took 2 9s are 18, again 1 is extra, so that 1 will be written. Now it is 12. Is 12 divisible by 2? Yes it is, so 6. So this is how we do it mentally if you have problem otherwise doing it. Okay, you may make a rough column, there is no problem with it, but you can do it this way also. So what is the answer? See the blue number that has been written, 396, 396. Again it is an even number, so we take 2 as the factor. Okay, don't think too much. If you straight away get a factor, just take it. You know the divisibility rule of many numbers by now, so you can check and you take it. Again 396, I'm going to do it mentally. Is 3 divisible by 2? No, it is not. So what can we take? We can take 2 1s are 2, but here it is 3. So 1 is extra, which will be written with 9, and this becomes 19. But 19 also doesn't go in 2's table, so we take 9s are 18. 2 9s are 18. And again 1 is extra, this becomes 16. So now it will go in 2's table. 2 8s are 16. Okay. So let's write that 198, whatever we got, 198, we have written it. Again it's an even number, so we can take 2 as a factor. So let's see now. 1 will not go in 2's table, so we are taking 19. 2 9s are 18. Again 1 is extra, which is coming along with 8, and 2 9s are 18. So we write 99 over here. Okay, now it is simple, isn't it? What can we take? We can take 9 and we can take 11, right? 9 11s are 99. You can take something else also, as I've been telling you again and again, your wish, totally. 11 is a prime number, children, so we factorize 9 as 3 and 3. 3 into 3. Now just quickly check whether we have got all even numbers or not. If there is a composite number, we need to factorize again, isn't it? So let's quickly check. Check. Circle them. And write the answer. So 2 into 2 into 3 into 3 into 11 is our answer. So this example was taken for you to see how do we factorize mentally if it's a large number. You may make a rough column and divide and see, not a problem. It is just a little time consuming, but you can do it this way, the way I just made you explain, isn't it? Okay. And now the last example, I've taken a larger number, a 4-digit number. I'm not going to explain much. Let's see whether you can understand on your own or not. It's an even number, so I'm taking 2 as a factor. So 1, 2, 1, 2. Simple number, we can factorize. 2 1s are 2, 2 2s are 4, 2 1s are 2, 2 2s are 4. So 1, 2, 1, 2. Again an even number, so I'm taking 2. Now here we need to see something, okay? Be very careful. 1 will not go, so 12, 6 are, okay? Now again 1 has come. 1 will not go. So you will take 12 and write 6, 6? No, you will not do that. If in between a number, there is a number that will not go and you have to make it a double-digit number, we put a 0, isn't it? Remember division? When we take 2 digits together, we take 2 digits together and we get them down, then we put a 0 in between. So be very careful. Then this 1 becomes extra and this is again 6. So 6, 0, 6. Don't write it as 6, 666. It will be wrong. Okay, there is 1. As you can see, I have underlined it. This 1 will not go in 2's table. 12 went. So 2 6 are 12. But this 1 will not go. That is why a 0 has been written. And then this 1 along with 2 becomes 12 and again 6 are. Okay, so 6 0 6. Now it is simple. Now I'm not explaining anymore. 2s are, again it's an even number, 303, and 3 is the first thing that comes to my mind. There is nothing else that is coming to my mind. 101. Now 101 is a large number, I know. It is a prime number, so I'm telling you this. It is a prime number. Okay, I'm telling you this. So now let's circle the prime numbers. I hope there is no composite number that I have left out. Is there any composite number that I have left out? No, there is no composite number. So let's write the answer. 2424 is equal to 2 into 2 into 2 into 3 into 101. I know 101 was a large number, but then I have done the sum, so no problem. This is the answer. This is how we factorize or prime factorize any number using factor tree method, children. This is called the factor tree method. Number is written on top and then you keep factorizing it, come down and then get all the prime factors, circle them and write the answer. When we multiply these prime factors, we get the original number back. That's the idea of prime factorization or any factorization for that matter. The only difference between factorization and prime factorization is prime factorization will have all the prime numbers as the factors. Okay? So you must practice, take any number, whatever comes to your mind and try and factorize them using factor tree